Welcome to this week's session on asset reliability information management. My name is Dick Hancock. I'm with 24/7 Systems in Knoxville, Tennessee as a reliability consultant. And our specific topic this week is the fifth in this series. It's about including walkaround inspections in your reliability program and the importance of being able to integrate that well. First, I want to review very quickly why worry about asset reliability and what are you really trying to achieve. We think you can boil that down into two broad goals. One is the shorter term goal of eliminating failures in service so that you don't disrupt production and run up maintenance costs unnecessarily. The second is a longer term goal of increasing operating life between asset failures by using a systematic approach that includes root cause analysis so that you can take the actions to mitigate or eliminate the reasons that you might be suffering repetitive failure modes in either specific pieces of equipment or locations of equipment. When we talk about reliability information management, we're talking about the volumes of information that come from many sources over the entire life cycle of the assets in an operating plant today. And that can include the information from the point that a piece of equipment is purchased either at new plant grassroots construction or in capital expansions as you go forward, and what happens to that equipment as it goes through the stages of life. It may go into the equipment inventory and be in a storage location, then go to an installation in a service location, on a base plate. After some period of operation, you may need a repair, and you might repeat that cycle of going to stores, going to a service installation, going to repair many times over the usable cycle of a piece of equipment until it gets to the point that it's no longer practical to do a repair or revival of that piece, and that piece of equipment gets scrapped. However, there's all of this information from the design, the warranty, initial cost information from when it was purchased, what happened when that piece of equipment went into stores, did the shaft, for example, on a motor get turned every month so that you didn't end up with false Fresnelling on bearings in large motors, or did the desiccant packages in that storage area get renewed every quarter? So you didn't have corrosion problems. Today, the topic we're going to be talking about on walkaround inspections falls more into the service installation phase, and we're talking about the importance of being able to combine that information that might be coming from this variety of walkaround inspections with the other kinds of reliability activities that are typically going on in many plants today, things like condition monitoring using vibration analysis, infrared thermography, oil sample analysis, motor testing, other types of non-destructive testing to be able to predict and handle problems before they become an emergency work order. We're going to specifically talk about merging in the results and the knowledge that's being generated from these walkaround inspections in that period. Now, unfortunately, when you think about that volume of information, the typical state and still far too many plant operations today, even when they are conducting a lot of reliability activities, is that we end up with a lot of that information in what I call islands of information. The information from the vibration system may reside as the data in that vibration software that either the in-house techs or the service company is using, and what the people at the plant may get are reports, monthly, quarterly reports about what's been monitored. But once again, those are email items that are in an email list, and they have a lifetime that pretty soon they get overwhelmed because they're so far down the list. You may have to, if you're using that as your document library, it may be difficult to retrieve and even know what's going on. In other cases, we've seen a lot of reliability engineers, maintenance supervisors at plants put a conscientious effort to manage a lot of that information about what was measured when, what was found in Excel spreadsheets that they end up trying to update on a weekly or monthly basis, maybe spending hours trying to do that update, only to find that that piece of information is in that spreadsheet, and if it's not being circulated or communicated to others in the organization, then it's a handful of people or maybe even one person that knows the details that are in that sheet and can use it. The other problems we see is that because of this diverse makeup of these islands of information, is there's often no standardization on what the assets are called. The vibration software may have been set up with the naming of the assets coming more directly from nameplate data, while the other parts of the organization, particularly the work order maintenance planners, are probably working with a system where it's drawn from what was designed for the EAP or the CMMS system, using those very specific codes that are in those systems. As a result of being non-standardized and spread among these many sources, many files, many systems, you end up with no integration of the information that's coming from each of these different areas. Even within the more confined area of condition monitoring, it's not untypical to have a system or have people in the company that know information about a gearbox that's coming from the oil lab samples that maybe are being taken quarterly or semi-annually on that gearbox, and yet others, they may not be aware of calls that were made just the recent week by the vibration analyst who were doing a route in the plant. So that's a pure communication then of the available information about the known health of the assets, which is directly related, of course, to reliability. And of course, if I don't have communication, then it's very hard to say that I'm going to create accountability for the follow-up on that information so that we are making good decisions on what work orders need to be scheduled when in order to mitigate these potential failures in service that we want to achieve in that first primary reliability goal. So again, we've here at 24/7 put together a series of articles on the best practices in reliability information management. As I said, today will be the fifth in that series. The first were the importance of being able to get away from these islands of information by using modern cloud and web-hosted databasing technology to be able to centralize all of that reliability information in a single database that is then in turn available for access by a wide audience of stakeholders that need access to the information. The second topic was focusing on the importance of not dealing with the raw data that's, for example, the spectrum or the waveform that's in a vibration system, or the details of an electrical MCE test. What's important is to know what those technicians who know those technologies, what was their analysis? What did they say? What were their findings and recommendations about the health of the asset and particularly of any problems that were found? And I already mentioned this earlier. Our third topic was the importance of being able to segregate this information within the master database, master reliability database, so that you're actually tracking what's happening at a particular equipment location. Again, a base plate for a condensate return pump in a paper plant basement versus the information about the individual pieces of equipment that might be serving in that base plate today, but as it goes through life cycles might end up in a different location 6 months from now after it's gone through the repair and store cycle. It's important to know that difference so that you can, in terms of figuring out those root causes, get a better insight as to whether the problem seems to be following that piece of equipment around as it migrates base plate to base plate, or is the repetitive problem mode more associated with a single base plate location. Finally, the fourth item was we talked about the management of the condition monitoring task, the vibration task, the infrared thermography task, by using the single cloud reliability master database to track all of the scheduling and the results that are coming from those and being able to post those in a single dashboard location. So with that, it brings us up to topic number 5, why it's important to include the walk-around inspections in your reliability program. So what are we talking about with walk-around inspections? Specifically, I'm going to be talking about the things that you have in basic operator care or operator-driven reliability, where you have shift inspections or maybe not once per shift, but weekly scheduled inspections being done by the equipment operators. You have lube techs in many plants that are out running lube routes and visiting those pieces of equipment up close and on a daily basis. You have mechanics and electricians that are doing inspections, calibration checks, calibration audits. You even have things like safety and environmental inspections that are going on. And in every case, you have people that are typically up close and personal with the assets while they're in operational mode. And we think it's important that the people in the reliability and the maintenance organizations really should be able to know what those people are finding about, particularly about developing reliability problems. So As I said, operators doing basic inspection care, lube techs, mechanics, electricians, safety, environmental inspectors. And this all fits right in with the growing importance of the relatively new ISO 55000 asset management standard, because the key is being able to say what you're going to do, document what the plans are, particularly for inspection and reliability activities, and have an audit trail to know whether or not only what's being found, but to know that those inspections are complying with a specified schedule. In other words, say what you're going to do, and then be able to prove that you did what you said. Unfortunately, still today, I come across a lot of plants where they haven't automated or they haven't digitized the walk-around process. In many cases, they're depending on the work order system to say it's time to do a utility room lube route. And okay, that's pretty good for scheduling, when that's due and whether or not the work order got completed. The feedback I've had is at that point, all I know is that we did something in the utility room. I don't really know how many of the assets the lube tech touched, how much grease he added, how many compressors he might have found that were low on oil and needed a lot of makeup oil. The details, the content tends to be lacking when I'm depending on the work order system to trigger what I'm doing on my walk-around inspections. And furthermore, even if I'm using the work order systems for the scheduling, the most typical process that I run across today is people still using Excel forms that get printed out. The technician or the operators stick those on a clipboard, and off they go to track this information on a piece of paper. And those guys do a good job. They go out and fill in the blanks just like they're supposed to. But unfortunately now all of that information is trapped on that paper form unless somebody's going to take the time to translate it into a digital format. And I'm not aware of too many plants where that happens. I hear more often is that the piece of paper ends up in a stack or in a file cabinet, and maybe they get dug into when the insurance auditors come to visit 6 months from now just to see if we don't have enough documentation to show that we in fact did those weekly inspections in the utility room or the monthly lube routes the way we were supposed to. A better practice is to digitize that process. And that's easier today than it's ever been before. And we think there are really 3 key steps to that. Number one, and for those plants that in fact already have that set of Excel files, for example, that are the guides for the sheets of paper that get printed out and put on the clipboards, then that's an excellent starting point. With databases like SQL databases, it's usually pretty easy to do straightforward imports of what those task items are for a particular inspection route. The big breakaway is get away from the clipboard and use your modern smart devices for field collection and communication with the master database. And there's certainly a lot more of that starting to happen, but it's not everywhere yet. Still also is missing, even in many cases where I see people working toward digitizing their inspection process, is having that good audit trail, making it where it is easy to retrieve from a single database location. Did we measure what we said we were going to measure when we said we were supposed to measure it? So the first step, this is an example. It's a system that we provide, but it provides the ability to provide those inspection definitions so that you include a route name, when you're supposed to start it next, how often it's supposed to be repeated, whether or not there is one individual who is supposed to own that route and be the person that does it on a repetitive basis. I probably see 2/3 of the groups that we work with working to assign users to be the owners of a particular route, and maybe the other third are pulling from a pool of people to be able to do that. For example, if I'm doing shift inspections, I may not know who's going to be on second shift each day of the week. I don't want to create an assigned user. We have the ability here, you see that they create task group names. This is part of that report retrieval and auditing process to make it a lot easier to say that I want to look and see what we did, like in this case, on the 7 paper machine route area for lube routes. And bottom line is I'm getting down to specifying what I'm going to measure. I'm going to record grease added on a bearing number 1 on a rider roll on the 7 paper machine in the 435 winder section. Here I actually have the information that says this is the rider bowl bearing number 1. There's only one point that I'm supposed to grease, and I'm supposed to use the SHCPM 460 lubricant that's on my grease cart. After I've recorded the grease added on bearing number 2, I'm also then supposed to inspect the lube lines and fittings. And what I'm going to talk about is there's fundamentally, when we've gone through many of these spreadsheets that people provide to us to as the starting point for digitizing their walk-around inspections, we have 2 fundamental kinds of route points. And so when I see those show up on the screen of a tablet, one type is what we call a trend point, where I'm asking simply for a numeric input. I want to measure a inlet pressure on a compressor and a discharge pressure on a compressor. So I'm going to have a numeric input that's going to be defined in either degrees C or degrees F or PSI or kPa, whatever my unit of measurement is. The second type of measurement point that typically gets set up, and these are the ones that are far more customizable, are what we call observation points. They are expecting the data input to be a text string. And in order to make these standardized, the best practice is to create a pick list that's appropriate for that measurement point. So you'll see, for example, on the right-hand side of the screen, where the observation direction is to check the oil condition on this particular gearbox, then I'm going to pick from an item list that says I'm either finding the oil condition to be good when I look in the sight glass, or I see that it's foamy because there's air in it, or that it's milky because I've got water or coolant present. It's dark or discolored because it's oxidized, or I see something else. Maybe it's actually a leak, and I want to add a comment, so I can also check add comment. The important part is that by digitizing this, kind of unlike going beyond what you can do if you're in a paper system on a clipboard, is now the logic can be applied that says which of these items, which of these measurements represents a machine or an asset that's in a good operating state of health versus a potential problem or an existing problem. So you can designate on the observations which of those items in that pick list are measured no problem, everything's okay, versus there's a potential problem and we need more information. So obviously in that pick list we're looking at, good would be a measured no problem, and as soon as I picked good, it would take me on to the next measurement point because I don't need to tell it anything else. Whereas if I had selected foamy or milky or dark, discolored, or add comment, those represent the need for additional information about a potential problem. On the trend side, in our system, you can actually set up both low level and high level alarms if you want to create a window alarm. That's not necessary. You can set up the single point, either low side or high side alarms as well. So basically that's what you're doing, is simply putting that information that's been defined as what is it I want to measure and what are the expected inputs that I want from my operators or my lube techs or my mechanics or my electricians into a database. Those are being formed into routes that are downloaded into smart tablets. And certainly with smart devices, if your plant allows it, you get some additional good features such as download documents. Maybe there are safety documents that the technician might need when he walks up to an electrical panel and he's supposed to be doing some certain kinds of measurements or maintenance or PM activities on that panel, and the abilities there to be able to take photos and link those to the information about a reported potential problem. As I said, I already kind of went through the alarm notification. What happens is if I violate one of those trend alarms, either on the high side or the low side, or if I pick a pick list item on an observation that has been marked as out of bounds, then I get a simple screen that says, tell me more about the potential problem. And I'll show you then, this is the key to being able to integrate this with the asset health information that's coming from your other, perhaps more sophisticated monitoring technologies like vibration analysis or thermography or ultrasonics. Because I'm going to be able to take this information from the technician, the operator that's doing this walk-around inspection, and escalate it up through a process in the cloud database so that it gets integrated with findings that are coming on a particular motor or a particular gearbox. And the findings that are coming from the walk-around inspection are going to end up right there alongside any findings that are coming, any potential problems that are being reported by those more sophisticated technologies like vibration and thermography. And it's as simple as soon as I violate an alarm, I get the additional screen and I'm prompting that operator or that technician to tell me more about why there may be a problem or what they're seeing, or they can go to that button at the bottom down there on the lower left and take a photograph of a leaking seal, for example. Once that's done, now we're in the domain of and they've completed that route, we're in the domain of how am I escalating that? And the process is that the summary report for each individual route brings any of the alarm or out of bounds items to the top of the list, and Cloud Database can trigger emails to a set of specified users. So as soon as this report or this route, for example, happened to be this was on the 7 paper machine. It was being done every 2 weeks on the wet end, a lube route. And as soon as Matt completed this route back in April, if those emails had been set up for an area supervisor, a maintenance supervisor, a reliability engineer, then they would have been notified that this route had been completed. And by the way, there was one problem that was found on the lube lines and fittings on the wire return. And it looks like they had a grease line that had broke loose from the plastic line to bearing. So obviously, whichever bearing that line was servicing wasn't going to be getting any grease. And at this point, the only thing that needed to be done, or the process works so that now that the notification has occurred, again, one of the benefits of that master cloud-based reliability database is the notification of those who are perhaps authorized to make decisions about work orders or work requests, the ability to say, I want to escalate this up to the level where it's going to get the attention, the next time we have a review meeting with maintenance planners, maintenance supervisors. Maybe I'm having that every 2 weeks. And to do that escalation, all they have to do is to click this Add Entry button, and that's going to create in our nomenclature what's called a condition entry that goes to a dashboard, a browser-based dashboard, so that, in this case, this visual inspection, this one happened to be on a crane, shows up on this dashboard with a high severity indication that, something needs to be done. Once again, once that condition entry is made, I have the ability to trigger emails that tell me that this particular walk-around inspection has been completed and that there's resulting information that some set of people need to know about. I then have the ability, or the system, the master database has the ability to say, okay, now that we've made the decision to escalate this to the dashboard of known health problems, I can notify a different set of people, such as the maintenance supervisor or maintenance planner, for that number 7 paper machine area. This one's a screen capture from a steel plant, it looks like, or a primary metals plant with a hot line and a carbon plant and a cooling tower. But the point is I get that it's communication. The digital world around us excels at the ability to get the word out on a proactive basis to those that need to know specific pieces of information in context, not just send everything to everybody, but at all the steps along the escalation process are the correct people being notified about what's going on. And by the way, we're going to be going into the importance of this browser-based dashboard in the not only distribution of information about asset health, but also the communications and the creation of accountability for the follow-up on these problems so that we find out whether or not work orders are being created on a timely basis, whether we've got other problems that are preventing proactive work from being done as we would like to see it done. That's going to be our topic in session number 6 that will be scheduled in October. So now for the last part of my presentation today, the last thing I said is it's also, or in the important steps, is it's very important to know, are we actually doing what we said we were going to do when? So you need to have the ability to track route adherence. It's important not just to look at whether or not a route was completed, but we think it's equally important to look at what happened on all the points that were on that route. And again, this is the weakness I started off with, where people are still expecting just a work order tracking system to give them the vital information, because, I mean, it may say we completed that route, but we don't know if they collected information on 100% of the items in that route? Do they collect information on only 50% of the items in that route? Out of the points they did collect, how many were measured with no problems found versus how many were measured having a potential problem? Even better yet, how many did the technicians attempt to take a measurement on, but there was some valid reason why they could not succeed? If they were doing something that required the piece of equipment to be in operation, and they did their route and the piece of equipment was down, maybe locked out for some a planned outage even, then you need to be able to track whether that not measurement occurred, so you may need to go back and take a look at it at an interim period. So having a route adherence system that can interrogate the master reliability database quickly and pull up where you're at on both route completion and your point adherence, we think is very important. And for example, I've had one gentleman, one reliability engineer at a plastics plant here in the U.S. Midwest. He said it was just amazing when the insurance auditors would come in and, of course, started asking questions about, well, what is it, what's your plan, what's your program supposed to be, and then get around to, by the way, what happened on that measurement that was supposed to be done in March of 2020, when these people could bring up the report like this and scroll down and find the route and the occurrence of when it was measured in March of 2020 and show that they had measured maybe 100% of the points and found them measured no problem, or they weren't able to measure 10% of the points, but they got 90 of the points measured and 5 of them had a potential problem. Anyway, this reliability engineer said pretty quickly on the next audits they didn't get asked such detailed questions because the auditors were pretty impressed that they had that type of adherence information at their fingertips. So that concludes my topic, on this particular best practice. Certainly, if any of you that are participating would like a little more information, would like to take a closer look at our system, then we'd be happy to work with you on that and arrange a private, customized walkthrough on how the actual tablet systems work, how the overall reliability information management systems work. In the meantime, we certainly invite you to look out for the email invitation on our next presentation, which is where we're going to be talking about that condition data dashboard and how you can keep track of all the actionable information coming from your health monitoring, whether it's walk-around inspections or your more sophisticated condition monitoring tasks that are being done, and see all that information in one place and use it productively in your reliability and maintenance organization. We look forward to seeing you on our next presentation in a few weeks in October. Thank you for your time this afternoon.